I'd like to thank the good folks over at PCB Way for sponsoring this video. PCB Way is your one-stop shop offering a fully featured PCB prototyping service with low cost and fast turnaround times. Along with that, they also offer CNC machining, 3D printing, sheet metal fabrication, and injection molding, and many more services. PCB prototyping the fast and easy way. Thank you again, PCB Way, for sponsoring this video.
Alright guys, here's an old YouTube classic, except this one's made out of crutches. Old crutches that I've thrown away. And there it is, just a real simple magnet with a, motor with a commuter that's about to fall off. If you could see right there, it's sliding off. Well, all right, I wanted to show you my progress so far. I finished this guy. It's just a regular pulse motor using a Hall sensor. And this coil, you can really see it, this coil happens to be an older coil I had from a while back. It is a bifilar coil with, I think, 22 and 26 gauge wire. Right now I have it hooked up to run off of the finer gauge. And then we have the output of the larger gauge, which puts out a couple of volts AC. I'm going to rectify it, but let me show you what it looks like. You have to give it a little start. It's got a lot of power. Really quick, here's the setup with the flywheel combination generator that I was talking about. And that puppy is heavy, and this guy still spins pretty good. And around it are rare earth magnets, not as strong as the Neos, but they're still very strong. And I have I'll stop it in a second and show you. And I was actually thinking about putting magnets on here to act as yet another little rotor. See if I can't get a spin out of it just for giggles. Alright Rob, this is my new setup. Here's with the commuter I showed you in the last video with that weird setup. Just a couple of magnets and a good old reed switch, man. I'm telling you, I had the mechanical switch on there and it was just terrible. This coil right here is just a bifilar coil, probably about 800 turns, a homemade job, air core, and it's got this thing going pretty nicely. This is the new Newman motor, the bigger one, and it works pretty good. I'm using a bearing for the main connection instead of just running a wire, which seems to reduce the sparking and lowers the shaft heating up. And you were right. I had some ceramic magnets on this, and I just had them on there with a rubber band, and I had this thing flying, and they came flying off. So yeah, you were right. Okay, I got to record this really quick. I have to hold it up because I don't have a stand for it. But it's definitely going. And that's the bigger one. And it is flying. There it is. I just wanted to set up something really quick, so I used the 4-prong Hall effect. And that's at 2.7 volts. And it's flying.
So G-Law, thank you. The fourth magnet did the trick, so now I have both the large and the small. All right, just a quick one. I've been setting this thing up because I wanted to use the good rotor again. So I've got a drive coil here with the JL94 circuit. There's my load with some drilled out plastic on it. And then here's my pickup coil. I haven't got it hooked up yet, but what I wanted to show you was that everything here is 3D printed. The mount for the coil here, 3D printed. The mount for this guy here, 3D printed. And the mount for the back coil. Here, hold on a second. Let me pause this. With this JL94 circuit, sometimes you got to get it going, but it's flying, and that's at 12 volts. Let's turn it down a little bit. My video turned off. I think I was talking about if I just put another screw in the back of this one here, it should stop the vibration. Those, you can see. And it is continuously picking up speed. I'm at 12.8 volts. Let me turn it down to just 12. There's 12.5. It's picking up speeds. This thing is massive, so it's going to slowly but surely pick up speed. Wow, that runs really nice. Obviously, I found the pancake coil. It runs a lot truer than I thought. Here's the output. Again, it's flashing on the camera, but in real life, that's at 12.4 volts. There it goes. It's got a nice sound to it, and you can see it's putting out a lot of back EMF through this beautiful circuit. God, that is nice. So yeah, I want to put a coil here, and see what I can get off it. I'm wondering how much it's putting out here. Let me set this down and take a quick reading. Oh, I'm gonna have to put you guys on pause. Hold on. Sorry about that. I can't find my stand. So it's putting out 10 volts coming to this little light here. But yeah, it's nice. This platform's got a little bit of vibration to it. I have it on 5.9 volts, like 6 volts. And it's going at a pretty good clip. But you can see the whole point of all this testing was just to make sure that the coils worked good and everything was sound. And it is. I mean, it's going really well. Oops. Let me take this off. It's going really well. I think I've got it secured now. But you can be damn sure before I test it using the commutator and stuff, it will, I will make sure that it is secured. All right, there you go. This is the new circuit. And of course, like I've always say, it looks different in real life than it does on the camera. But this circuit has a pot that I can adjust. So this circuit was not meant for something like this. Oh, wait a minute. Hold on a second, stay tuned. There we go. I think even on the video you can tell that it's flying. And of course that pulsating light isn't like that in real life. So this circuit is not meant for a rotor like this. It's meant for the maglev. And it is flying. Now it's doing well. Still putting out some decent output. Oh, if I pull the... See, this is what surprises me about the Hall sensor circuit. If I pull the coil back, it actually speeds up. Yeah, she's flying now. I have to figure out the back plate. That's what's causing all that racket. 14. That is flying. I better be careful. Let me turn it back down. Because although I trust that shield, I don't know how much I trust it. But yeah, there's no wobble in that puppy now. Solid light. Yeah, that is gorgeous. Let's take a look at it from the... That's why I love those VCR bearings. And I was just playing around in here. I hadn't planned on making a video because I was looking at this coil and I was looking at some of my other coils that I have here. Some I made, some I got from Sky. And I just got my hands on a 450 volt cap. It's not as powerful as these caps because these caps are 500 farads. This is, I think this is 1,000 microfarads. I'm not really sure. I think that's what it is. But I wanted to use it because it's a 450 volt. I want to charge it up and see what I can do with it. First, I want to charge it using this system, using the back EMF off of that, running it. Actually, I think it should be able to work just the way it is. Well, there it goes. I had to hook both of the coils up to the both circuits in order to get it to go. A single circuit with a single coil doesn't seem to work, and even with this, I have to have it at like 18 volts. So I have one going off to the super caps and one just going off to this LED. But it's going now. All right. He's going good. I want to try a Hall circuit on one of these. First, I want to put my bigger coil on there. And if I'm going to do the Hall circuit, I need to mount everything down so it doesn't flop around. All right, let me turn this off. Stay tuned for hopefully not a disaster. Yeah, so with this particular rotor and with the Hall, with the JL94, I really have to get the coil close to it with this rotor setup. Of course, this is a beautiful coil, but as you can see, it's working great. Yeah, 12.6 volts. Working really well. So yeah, with this particular rotor, the Ferris wheel rotor, I guess we're calling it, and set up the way it is, I have to get the coil really close to it, like that one there. I wonder what would happen if I were to put a Bedini coil there with a JL94 circuit. Okay guys, so I got it back together. As you can see, spins really nice, really loud though, because I couldn't figure out a way to put some sort of bumper or rubber on the rollers. So I have it hooked up with two JL94 circuits connected in parallel to the power, connected to these two coils. 12 volts, and it runs a lot faster with the new magnets. In fact, I've got to turn it down to 10 volts. I've got it running on 7 volts now because it's just way too fast on 12. So let me turn it off. Wow, what a difference. So I set it up the same way Sky does. And it actually, stay tuned. I was being summoned, sorry about that. So I set it up exactly the way Sky did. And it actually auto started. As soon as I turned the power on, it took off. But it's so quiet. And I did it the way he did it with the coil. And actually, I don't have it centered properly. That's okay, I can fix that. Have the coil on the side and the hall sensor right in the center there. So that's how I'm going to set up the new one. And I'm also going to have a pickup coil on that side. So I got it all set up. You can see this is the magnet end that pulsates back and forth. I don't know if you can see that. And there's the magnet. Goes around, connects to this guy. Well, it doesn't connect to that guy, but let's see how it works. Ooh, self-starter. Working pretty good. A lot better than the other one. A lot faster too, much quieter. That's pretty cool. Can't really see any sparks though. Not that I want to see sparks. Keep the top on. Yeah, that's going much faster than the one that had this guy here. And I'm still using this for the main shaft. I'm gonna be using that always. So let's turn it up. This is at 12 volts. There's 14. There's 16. Really quiet. There's 21. Now you can see some sparks. It works pretty good. It makes a rattling sound because I put washers in there, which I probably shouldn't have. But it's really smooth on the ceramic bearings. And again, this is not a very big coil. And I always thought that I needed a big coil to run this circuit, my new favorite circuit, the JL94 and JL93. So one is a trigger, the other one's a run. I'm assuming that's how it works. And it's working fine. Let's see what happens. So really quick, nothing is tied down here. In fact, yeah, you can see how it's sliding over. Nothing is tied down. I just wanted to show you how nice and balanced it is. This is using the hall sensor. And it's not tuned correctly but it's balanced beautifully. So I'll set it up shortly with the JL94 circuit. I still have to cover the rotor too. But the hall sensor's working great. The Hall sensor's working great. One of my biggest character defects is that I am freaking impatient. So when I get impatient, I break out the hot glue. So this is what it's supposed to look like running off of a good coil at 12 volts. What I did was, this was normally a Bedini coil that Sky Collection made for me. So I jumped the positive and negative of one of the wires. So now it's one continuous wire. Pretty simple stuff. Nice and slow, starting at low voltage, 6 volts. There's 8 volts, starting to get some output now. There's 12 volts. So this is not set up to work like on the JL94 dual circuit. Let's crank it up. Let's really crank it up. 22 volts. I mean, it works great, but I'm surprised. I guess because of the thickness of the coil and the heaviness of the rotor, it's meant to do more as a Newman motor type setup, which is cool. I've got all that set up for that as well. There we go. And so this is the one that's only 5 volts because of that special Hall sensor. So the 2 outside leads go to power, the 2 inside leads go to the coil. I just have it kind of floating there. 3D printed, 3D printed, 3D printed, which is freaking awesome. There it goes. So the distance is really far. So, and I did that on purpose so that it wouldn't go too fast. But that's at 12.6 volts with a good 2-inch distance there. But look at that. Oh, that is gorgeous. Welcome back. So these are the 2 coils from the Newman motor, and I wanted to see how they would work outside of the Newman motor environment in one of my big monster rotors. This is the maglev. It's being supported by that magnet there, and it just so happens that this is just tall enough where the screws still catch. I need to put some spacers underneath here because I have a little bit of a gap, but it doesn't really matter because this is locked down tight. These aren't going anywhere. So yeah, let me get my dual JL94 circuit hooked up to these 2 beasts and see what happens. Stay tuned. And it works really good. I'm getting solid output. It's flashing on the camera, but yeah, those coils are nice. This is at 12 volts. And it's flying. I know the camera doesn't pick it up. I should probably get out of the fire of the magnets, although I do have an extra ring on there, and that ring is made of copper infused PLA. And I think I have, let me get my, yeah, it's continuing to spin up. And then I can test putting the iron cores in, and then test not hooking all of them up, only hooking a couple up and a couple for output, I really like this motor. It came out really nice. It was really well designed. Redesigned 3DP's the gentleman who designed it. There's his logo right there. This is one of his motors. And it's designed really well. I mean, the bearings are being held in place by the rotor brakes. That's what he's calling them. Yeah, it just fits really well. It was very well designed and really easy to put together. So stay tuned. All right, so I've got it up and running. It's running really well too. It's only running off of 2 coils. I quickly learned that with this kind of setup, let me turn it down a little bit. With this kind of setup, it's running really well. With this kind of setup, I can't run 5 coils in series and expect it to run off of a JL94 circuit. So I have the 2 bottom coils here engaged, and the top ones are not. Oh my God, let me turn it down. So it's running on 6 volts right now, and it's still running really well, putting out some decent output, solid output. So as you can see, it's running great. Let me turn it up a little bit. Yeah, it's running like a monster off of the JL94 circuit, the dual circuit. It likes to run at higher voltages, but this is at 13 volts right now. Got a solid output. I really love this motor. Working good. A lot of good output. That's only 8 volts too. Let me turn it down a little bit because I don't have the... I mean, I'm 99.999% positive those bearings aren't, those magnets aren't going anywhere. But that's 7 volts. This is a great circuit. Let me turn it down again. There's 6 volts. That's working really nice. It's going a lot faster than what it's showing on the video. That's always the case. All right, so I got it hooked up to the dual circuit JL94 circuit. Got the 2 smaller coils from the prototype Newman motor. Let's see what we got here. I'm only starting out at 7 volts because I don't know how fast this thing's going to go, and I'm not 100% confident with those, the way those magnets are clamped on. Even at 7 volts, it's flying. Putting out good output too. All right, let's crank it up a little bit. 9.6 volts. Really good output now. So the lights are solid on my side. Oh, they're solid in the video too. Well, kinda. And yeah, you can see it's working good. And it is going extremely fast. I may have to slow it down. It's actually working great. Just afraid that it's going to shoot magnets off. It shouldn't though. Oh yeah, that's nice. Really good output. That's only at 9 volts. Let's crank it up a little bit. Oh yeah, I can feel the wind coming off of it. That is really nice and steady. Holy mackerel. Let's crank it up a little bit more. Here's 12 volts. That's without the guard on it. This guy right here. I don't know that it needs it though. Solid output. Blinking for you guys, but solid for me. I'd say that was a success. I have a new rotor in mind for these long bar magnets. All right, so I've got it running off of my homemade super cap bank, charging the one with the logic board on it. Yep, and here's the cabling from my power supply. Yeah, it's definitely running well too off of the super cap. I'm not sure how long it'll run for. And it's working pretty good. Got some decent output. I have the coils underneath using the dual JL94 circuit. 12.4 volts. I suppose I could lower it and it might even be better. But I think it's all right the way it is. Works well. I mean, obviously there's going to be cogging, but it's not. I mean, when I tried it before, oh my God, it was brutal. I don't know. Yeah, it's working well. That's interesting. Yeah, cool. So that worked out really well. Let me get things hooked up. Stay tuned. All right, so here we go. Not too bad. I'm getting almost 20 volts out of it. Yeah, I got to turn it up to the next one. 21 volts. That's 21 volts AC. That's not too bad. 23 volts. A lot of shimmering though. And it's because of this rotor right here. It's not balanced very good. I got to change it out. I have a better rotor to use as a drive. So 25 volts, 26 volts. Really good output on this side here from the actual circuit itself. So yeah, those coils are producing pretty nicely. I should have pushed them closer together, but it was scaring me with the way those large magnets were pulling on these iron cores. 27 volts, 28 volts.